All right, so chapter 6, we are going to be starting today all about weather and climate. And 6.1 kind of gives us a little bit of an introduction to weather and talks about wind patterns that we have here on Earth. So especially where we live, I think we are really tuned into weather, and that's because living in northern Minnesota, we have the joke about, just give it a second, the weather's going to change. And it really is the truth. We can have a temperature swing 30 to 40 degrees within a 2-day time span, snowing one day, sun's out, and you're in your shorts mowing the lawn, maybe in a couple of days after that. So what is the weather? The weather is the condition of the atmosphere at a particular time. We look at things like temperature, wind, atmospheric pressure, but weather is what's it like outside right now. So when we look at a forecast like that, when we see on the news, wouldn't that be nice right now? That's what the weather is. What is the condition of the atmosphere at a particular time? What's the weather like outside? It could be nice, or as you can see in the upper hand picture here, it can be not so nice. That is a picture of a hurricane. I mean, in a sense, when you look at that, kind of a pretty beautiful picture from the sky. So one of the big factors that determines weather is wind. So we spend a big part of this lecture on talking about wind. So when warm air rises, an area of low pressure is created. Like you see in the picture here, it's the orange arrows that are moving up. So when air gets pushed up in the atmosphere, because it's less dense, now, why is it warming? Think about all the things that we've just been talking about. When the sun's energy reaches the Earth's surface, it heats it up. So those molecules, because they're moving faster, they're going to move away from each other. They become less dense. As they go up in the air, they create this area of low pressure underneath it. Because there's less molecules there, other molecules want to move in. They want to push in there. You just created a void. You created an area where there isn't anything there. That pushing in of those new air molecules is essentially what wind is. So low pressure area draws in air from surrounding high pressure areas, and that is wind. So it's going to move from high to low pressure. So that's how wind moves, from areas of high to low pressure. Eventually, the warm air that rose up in the Earth's atmosphere cools, becomes more dense, and creates areas of high pressure. So sinking cooler air creates areas of high pressure. So dense cool air sinks back to the surface, causing an area of high pressure. This new high pressure may become the source of more wind. So really, when you think about it, what is wind? Wind is created when air masses with different pressures move. So high to low pressure, that's all wind is. If you go outside and you feel wind, you are just feeling air with a different air pressure moving in. Now, depending upon how different that pressure is, you're going to get the different wind speeds. So the greater the difference in air pressure, the greater the wind. I'll say that again. The greater the difference of air pressure, the greater of wind you are going to get. But typically, how it's going to work is you're going to have from high to low pressure, just like you see in the picture here. And just another refresher, when air gets pushed up in the atmosphere, creates an area of low pressure underneath it. Sometimes we get these small upward flows of warm air. They are called thermals. Remember, therm means heat. Airplanes and actually birds can even catch a ride on thermals, saving them energy. Great thing for birds if they don't have to flap their wings to get somewhere. They can use the wind for that. That's an advantage for them. But when it happens on a small scale, we call those thermals. So what happens on Earth is we get these patterns based on how Earth typically heats up. So keep in mind, just like we learned in the last chapter, the equator is an area where we get this just consistent sunlight at all times. So it really creates an area where you have all of this air that is constantly getting heated, and look at what type of pressure zone you have near the equator. So right in the middle there, where it's at 0 degrees, we have those L's because you have warm air that's constantly rising from the equator there. Near the poles, so near the North Pole and the South Pole, we have the opposite happening. It's going to not be warm there. It's going to be cooler air there, more dense, so it's going to create areas of high pressure. So we get these things called convection cells on Earth's surface. Remember, convection means circulating, just like you see in this picture here. Combination of global convection and Earth's rotation set up a series of wind patterns on Earth's surface. So you'll also see that with the purple arrows there, we have other patterns of how the wind blows on Earth's surface. So global wind patterns just come from our patterns of how Earth's surface is heated up. Now, when wind blows on Earth's surface, it doesn't do so in a straight line. Why not? Because Earth is spinning. So if you've ever been on a merry-go-round before, imagine you trying to throw a ball to someone who's directly across from you on the merry-go-round. You're gonna have a really hard time doing that. That's because you are spinning. So because Earth is spinning, air currents actually bend on Earth's surface. So all because we're spinning. Another great analogy would be like a lazy Susan. If you guys have one of those at home, you have a lazy Susan and you try to spin a marble straight across on a lazy Susan while it's spinning, it's not going to happen. It's going to rotate a little bit. In some of the videos I have you guys watching this week, you can actually see this happening. It's a much better, easier thing to actually see than to have me describe it. So what happens is in the northern hemisphere, the winds will actually bend to the right, and in the southern hemisphere, winds will bend to the left, just like you see on the picture here with the purple arrows. So what that means is if you're a hurricane in the northern hemisphere would bend to the right, going in the clockwise direction, whereas in the southern hemisphere, they're going to go in the counterclockwise direction. Also, the reason why if you're a hurricane, if you're going across the hemispheres there, so from northern to southern or vice versa, it'll actually slow them down and they will not continue to move, because it's, imagine like being on that merry-go-round and then something's trying to push you in the opposite direction. So the Coriolis effect exists because Earth is spinning, so winds do not go in a nice straight pattern. So typically all of that cool air is going to move down towards the equator, but it's not going to do so in a straight line because we are spinning. So global winds happen on a global scale. So we have two different types of winds. We have global winds which happen on a global scale, and then we also have local winds which happen on a local scale. Makes sense, right? So there's three important global wind patterns that exist in each hemisphere. First of all, we have from 0 to 30 degrees, so we have either 0 to 30 degrees north or 0 to 30 degrees south. We have what are called the trade winds. Now, the trade winds are given their name because they're what ancient, I shouldn't say ancient, but people in European times, think of ships sailing goods across the seas. They would use the trade winds. They would hitch a ride on them to move goods throughout the world. So they go from 0 to 30 degrees. And as you can see in the northern hemisphere, how the purple arrows move, how they're going to flow, and in the southern hemisphere, how they're going to flow there as well. The prevailing westerlies get their name because look at where the wind is blowing from the west. So it's going to go from 30 degrees north to 60 degrees north, or 30 degrees south to 60 degrees south. And that should look familiar to you because where we live in northern Minnesota, we have that pattern where we typically see weather coming across from North Dakota, South Dakota into the state of Minnesota. Now you can see why, because that is the prevailing westerly. So that is how weather moves in most of the United States. It's going from west to east, and now you see why, because of the prevailing westerlies. Finally, we have the polar easterlies that are going to go from 60 degrees north to 90 degrees north, which is North Pole, where Santa lives, or we can go from 60 degrees south to 90 degrees south, which is going to be at the very bottom. So those are the easterlies, given their name because that is the pattern where the wind is coming from, right? It's coming from the east, it's blowing from the east. So it's kind of weird because we think of, you know, how weather affects us and what things are like, but imagine now moving somewhere else on Earth. Imagine moving to South America, and you can see how the wind patterns or the weather patterns would be totally different for people that live there. But these are global winds, not local winds. They happen on a global scale, all because of the heating and the convection patterns that we just saw in the previous slide. We also have some areas on Earth where there is not consistent wind blowing. They're called the doldrums or the horse latitudes. So those are areas, I believe the doldrums are at 0 degrees, and then the horse latitudes are going to be at 30 degrees north and 30 degrees south. But those patterns are set up because there is not a lot of wind there. So local wind patterns Besides, local wind patterns that you would have normally, we also see these local wind patterns called sea breezes and land breezes. Also another thing I think maybe a little bit easier to see in a video, which we have this week. So when you have really large bodies of water, they can affect local wind patterns. And us living near Lake Superior definitely affects, especially if you live around Duluth, Superior, you get local wind patterns coming off of Lake Superior, which is such a large body of water. Now what happens is during the day, the sun's out, heats up the land. Remember, land heats up really, really fast. So because the land's hot, the warm air is going to rise over the land, creating an area of low pressure. You have water near it, that large body of water, area over it, the water over the air over the water is cooler. So once again, here we go from high to low, high to low. So during the daytime, if you're near a very large body of water, you will often feel a sea breeze. It will feel cool to you. So if you're near the ocean, you're near Lake Superior, you feel the breeze coming off of it. And why is that? Like we just said, you're going to create an area of low pressure over the land because land heats up faster. At nighttime, you have the opposite effect happening. So that land cools off really fast at nighttime because it has a low specific heat, creating an area of high pressure. The water's still warm from the daytime, so it creates an area of low pressure. So at nighttime, if you're near a large body of water, you actually feel a breeze going out to the water. So those breezes, those local wind patterns, are called sea breezes and land breezes, and they all have to do with the specific heat of water because of water taking so long to heat up, cool off, or land having a low specific heat. Jet streams are something you may have paid attention to before as well. If you've ever listened to the news, definitely affects us living in Minnesota here. So when you have warm air and cool air meet each other, you can get what we call jet stream patterns forming. They're high altitude, fast moving streams of air. You may have heard of them before. They're called jet streams because, let me click back here in a second. You may have heard of them before because if a pilot can catch a ride on one of them, it can save them a lot of fuel, can save them a lot of time on a flight if they can hitch a ride on that jet stream. But definitely affects weather, it can push cool air down, can also bring moisture and temperature down in the area depending upon how far south it moves. Here's just another kind of cool picture of a jet stream right in the middle there. Last thing this section talks about is water in the atmosphere, which obviously plays a huge role in weather. Water and gas form in the atmosphere is called water vapor. So when we're talking about water in the air, it is called water vapor. Like a soggy sponge, air reaches a point and it can't hold any more water vapor. So think of air like a sponge. There's times when air can hold more moisture, and there's times when air holds less moisture. Think about when you are warming up air, you're taking those molecules and you're moving them farther apart. You're making the sponge bigger when the air is warmer. When the air is cooler, those molecules are closer together. You're making the sponge smaller. So we actually measure how much water vapor air can hold, and we call that relative humidity. So a measure of how much water vapor an air mass contains is called its relative humidity. And as I was just saying, warm air holds more moisture. Those molecules are farther apart. Cool air holds less moisture. Those molecules are closer together. We know this though. Think about where we live. Think about in the summertime when it is warmer, all of that humidity in the air. We don't get that in the wintertime though, do we? We don't get the humidity in the air because the molecules are closer together, so you can't put as much moisture into the air in the wintertime. The reason why we have to run the dehumidifier in the summer and the humidifier in the wintertime. So if I take just one last thing here to wrap it up, if I take on the bottom there, if I look at an air mass, if I took that same air mass and then I shrunk it down, you're going to increase relative humidity, right? Same amount of moisture, but if I change the volume there, think about that. So smaller volume holds less water vapor. All right, so relative humidity is just how much water vapor is in the air. We're talking about our days in the summertime that are just unbearable. We're talking about a 90% relative humidity. So when you think about that, that air is holding 90% of the moisture it can at that temperature, which is a lot. So just remember, weather is what is the condition of the atmosphere at a particular time and place. Is it raining? Is it snowing? What's the temperature? What are the clouds like? That is what weather is.